Hello, my name is Martin, and I'm writing a paper on the P versus NP problem. It's the answer to the paper written by Stephen Cook, or it is my answer. This answer contains some mathematics, like directed acyclic graphs and so on. And because some people don't understand that right away, I'm making this little video to make it a bit easier to understand. So, just imagine you have this coordinate system with 2 points A and B, A being at x equals 0 and y being 0, B with 42, 0. So the x position is at 42 and the y position, the upward movement, is 0. So it is on the x-axis. Now, everybody agrees, at least to my knowledge, that the shortest connection between A and B is a straight line. And if I ask the question, how long is this distance, then most of you probably say it's 42. So I can ask a question now: is there a path from A to B that has the exact length of 42? And we can tell that just by looking at it, and the answer is yes. Now consider this graph, this new graph. We still have our A and our B with the same coordinates. Now we have a point C at 21, 0. So it is 21 in the x direction and is 0 upward. And now, if we ask the question, is there a path from A to B connecting all dots, with every dot being visited only once, that has the length 42? And of course that is just going from A to B through C, and the length is 42, so the answer is yes. Now if we consider this third graph with A and B at the same position, but C being slightly a different position, it is a 21 in the x direction and 4 upward, 4 in y direction. So it is not 0, it is 4. Now if we ask the question, is there a path from A to B going through all the other dots, which is only C here, that has the length 42? And we must say no, because going directly from A to B would be 42, but having to go over C, which is not on the line, on the x-axis anymore, but slightly above it, we know that this is longer than 21 and this is longer than 21, so we have a path length which is longer than 42, so we can answer this question with no. This graph does not contain the possibility of a path length of 42. Now we have a fourth graph with slightly different parameters. A is still at 0, 0. C is still at 21, 4. But B is moved slightly in that direction. It's not at 42 anymore. So now if we ask the question, does this contain a path from A to B connecting all dots with the exact path length of 42? We must say maybe, right? We're going to have to calculate it. It could be, because you know, this could just be 21 and this could be 21, so it could be 42. We don't know. Probably not, but it's still possible. Now if we make a slider complex graph, this is our fifth graph. Consider we have A at 0, 0, B has moved further to the left, it's now at 38, 0. Then we have dot C at point 21, 4, and then we have dot D, which is also 21 in X direction and 8 in Y direction. So now we ask the question, does this graph contain a path from A to B of exact length 42? We again can say possibly, because B is not at 42 but more to the left. We would have to add this plus that and C, or we could calculate it from this data. We could also go from A to C to D to B, so we have two paths we could go, and the two paths we need to check. So you can imagine the more dots you add here, the more combinations we get. Here, for example, we have a dot A at 0, 0, a dot B which is at smaller 42, 0, so it is moved inward somewhat. And then we have a lot of dots in the middle here, C to Z, so C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, U, and so on, which are all at about 21 in X direction and smaller than 1 in Y direction. I even have some below the X-axis that wasn't meant to be. And so all these dots C to Z are about at that position. So now if I ask the question, is there a path from A to B that goes through all the dots touching every dot only once, that has the path length, does one path exist that has the exact length 42? Now this is quite complex because you're going to have to, I don't know, what do you think you have to do? I think that even if you have 6 dots, 1, 2, 3, 4, 5, 6, and this being A, and this being B, even if you only have 4 dots in between, you already get all these possible combinations that you could go. And the more dots you add, the more combinations you get. So finding a solution is hard. On the other hand, checking the solution should be easy, because once you're given a path, once you have a solution, then you can just add up the distances between those dots, and you can say, oh, yes, this sums up to 42. So that's the idea of this paper.